Thank you all for joining us today for our Industry 4.0 educational series, which is sponsored by the Economic Growth Institute at the University of Michigan and the Manufacturing Growth Alliance. I am Stephanie Ludwig. I am a project manager here at the Institute, and I will be guiding you through the program today. If you're not aware, EGI has been working with small to medium-sized manufacturers for over 35 years across the state of Michigan, and we're really excited to be working on this initiative. Today, we have Prasad Balaga from Optizol to present a solution on high-mix, low-volume manufacturing. And after this presentation, my colleague Vikesh will provide some additional information on current opportunities and resources available to manufacturers interested in implementing Industry 4.0 technologies that have facilities located in Northeast Michigan and the Upper Peninsula. So with that, I'm going to turn it over to Prasad so he can share his screen and start the presentation.
Yeah, thanks. Let me show my screen. Thank Tiffany for a good introduction. And let me start my first slide. Okay. But the screen, I don't know how to minimize the screen. Okay, it looks okay now. I'm Prasad Balaga. I founded my company Optizol LLC in College Station in 2004 to help job shops with production planning and scheduling to improve productivity. I visited various types of job shops during this time. Fortunately, I got good experience with a variety of job shops. Today's talk is mostly based on my experience with the job shops. So the prevalence of job shops in manufacturing world, most job shops are found in SMEs, the small and mid-sized enterprises. And these are engaged in high variety make-to-order production. And these industries make a wide range of products using right technology, resources, skills, and expertise. And most of them are small in size and revenue, but pretty difficult for planning, controlling, and managing production. The examples are machine shops, fabrication shops, forge shops, tool and die makers, mold makers, print shops, like labs, custom manufacturing. So there's a variety of industries that belong to this category. But I see two types of job shops. One type is production lines, and the other, the rest. A job shop may be a single production line that makes different products, but there are different types of production lines out there. Case one, this is a production line that makes a moderate number of distinct products with variations in product characteristics. And you might know the mixed model value stream. That kind of systems are a special case of this. And this is a production line that makes a large variety of products with or without variation in product characteristics. And this is a third type of production line where the products may skip some operations. For example, product 3 skips work at workstation 2 and 3 and 6. And a job shop can be a production system with independent parallel production lines for making a variety of products. And for any product, there could be one or more production lines that can make that product. And job shop may also be a network of work centers with each job passing through a sequence of work centers for its process requirements. So the sequence of work centers may vary with the job. For example, one job may go through work centers W1, 4, 7, and 10. The other one may go through W1, W6, W8, and 10, likewise. And still there are more complex structures of production systems in job shop world, but I don't go into all those structures right now. Let me talk about a few important features of job shop production. One, the system is capable of making a large variety of products. Two, the demand is infrequent, uneven, and highly unpredictable for many products, not necessarily for all, but for many products. And the process steps and process times, that is routing information, can greatly vary with product. And customers are quite authoritative, unlike Toyota dealers. And customers demand delivery of the products by stipulated due dates individually. These due dates play a very important role in job shops. The customers normally place orders for low volumes, but some orders could be high volumes also. And job shop production management. I'm going to list some of them here, not all. One, the infrequent, uneven means highly fluctuating and highly unpredictable demand for products, and a rapidly varying product mix with variation in process requirements and acceptance of rush orders. These are quite common for many job shops, and changes in order of priorities, the due dates, quantities, and last minute changes imposed by customers in the existing orders, and unexpected interruptions in resource availability, like machine breakdowns and worker absenteeism, and long material procurement times and unexpected material delays, rework and rejections due to poor quality, and utilization of multifunctional machines and multi-skilled workers. It's always beneficial to use multifunctional machines and multi-skilled workers in small shops, but scheduling production with optimal utilization of such machines and workers is quite difficult, unless we use a good scheduling software. Next, multi-resource requirements of operations, like an operation requiring a machine, a worker, machine, worker, tool, zig, and all. And simultaneous progress of multiple jobs on the shop floor through different routings, competing for shared resources, vendor operations, they pose some problem, and skill metrics changing with the shift, and independent work center schedules. When the shop is large, different work centers, different departments, they make their own schedules and they try to synchronize with a lot of difficulty. And for a long list of job shop issues, you could see our web page. And a necessity to make products against received orders. Every job shop need not be necessarily make to order, but some they become automatically make to order. I'm giving a reason for that. In job shops which make a large variety of products, many products have infrequent, uneven, and unpredictable demand. And for those products, final goods inventory is not economically viable, and therefore make-to-order production becomes inevitable. In some job shops, certain products may also require pre-production operations like design and engineering. Some products may also need procurement of special materials after the order is received for them. And due dates and material release times, these two are very important in most job shops. The due dates can cause a lot of stress for production people. And material release times, they affect production lead times, work in process, and also on-time delivery. Job shops regularly need to perform many difficult tasks, which include the following three. One, quoting the earliest achievable due date for each order. In other words, quoting the shortest lead time, for each order, and finding the optimal material release time for every order, and making and delivering each ordered product by its due date. Usually salespeople, they don't always quote due dates in a rational manner. The due dates earlier than achievable will cause problem for shop floor people. The due dates later than the achievable will disappoint the customers and also carries a risk of losing the order. The problems with the material release times. There are some problems with early material release. If we release the material for jobs earlier than the right time, then these jobs will get stuck at bottlenecks and they wait for a long time. They clutter the shop and they increase the WIP, work in process, and also the production lead times will be longer. But there are some problems with the early material release. And if we release the material later than a right time, then the jobs may be delayed finally. But how can a job shop determine optimal material release times for jobs, particularly when the shop is not a production line? So one example is given here. If you release at the right times, then the jobs don't wait for too long. The waiting time is shown in the yellow color here. The production control, this is one of the most important, two most important slides in my presentation. I talk about the production control here. The production control will become simpler and easier in complex make-to-order systems when the material is released at an optimal time for every job. I'm not telling you right now how to find the optimal, but I'm saying if it is released at an optimal time for every job, and at every work center, the jobs compete for resources based on a predetermined prioritization policy, and the jobs are pushed across the work centers as they progress without any micro-level control like Kanban. So basically, release the jobs at the right times and let them flow through the system freely without any control. Keep pushing the jobs from one work center to others one. That will be the much easier way of controlling production. But the difficulty is to find this optimal time for every job. That these software tools they help you to find the optimal time for a material release. Such production control can be achieved easily with the help of good scheduling software. I see 4 sources of variation in job shop production. I have never seen any consultant talking about these 4 sources of variation explicitly. The variation adversely affects plant KPIs and increases the difficulty of production control. There are 4 types of variation. I'm going to list them here. 1, high variety of products with the large known variation in process requirements across products. Unpredictable, uneven, and infrequent demand for many products. 3rd category, uncertain events with a significant impact on production, like major machine breakdowns or long worker absence, or even major quality problem. They cause a lot of disturbance in production. And the 4th one is uncontrollable statistical variation. There's natural statistical variation in the system. The lean manufacturing people, they try to control the 4th one with standardization. So when you standardize, the statistical variation comes down in operations. And by having good maintenance program and quality management programs, you can also control 3rd source of variation. But the 1st and 2nd source of variation, cannot be controlled easily. But that's what job shops normally face. Lean manufacturing people, they do not consider the 1 and 2. Well, they try to do, what they try to do, they want to set up different production lines for different types of products, but that may not be possible in many small job shops. So these are small and mid-sized job shops. They have to face the source of variation 1 and 2. The above source of variation, they create a shifting bottlenecks. Because of these 4 types of variation, the bottlenecks keep changing on shop floor. So then we have to mitigate them. How to mitigate these temporary bottlenecks, which are caused by those 4 sources of variation? This occurrence of temporary bottlenecks is more prevalent in job shops. You might not find on a Toyota assembly lines or a GM or Ford. You won't find temporary ones on those mass production lines. The mitigation of some temporary bottlenecks can bring a significant improvement in plant production. I wouldn't say that mitigation of every temporary bottleneck will bring the advantage, because even if you mitigate a temporary bottleneck, there is no guarantee that it will have good effect on plant KPIs. But a good scheduling software, it helps you with the what-if analysis to see which one to mitigate it, which not. Suppose if I remove a bottleneck here, these jobs will go and sit there at the next bottleneck for longer time. It may happen. One of the approaches to mitigate temporary bottlenecks is to optimally make use of capacity buffers available at work centers as and when required. So what are these capacity buffers? These are, the examples of them are overtime of workers, addition of temporary worker resources, the machines or workers or tools, and next, outsourcing of some individual operations or sometimes even entire jobs. And capacity buffer is usually limited at any work center. We cannot hire temporary resources as many as we want. And we can't outsource also as much as necessary. And capacity buffers sometimes are insufficient to fully mitigate temporary bottlenecks. People take decisions in real time to make use of capacity buffers for managing these temporary bottlenecks, but this increases firefighting. So this is the second most important slide in my presentation. So this diagram shows 4 different scenarios of a flow of a work order in a high variety make-to-order production. Let me explain the colors. Waiting time of the job or work order at work centers. And the initial, the orange bar represents the waiting time for material that may or may not exist in every case. And all other colors represent the durations of operations. In the first scenario, the completion time of the job is far beyond the due date because the job has been waiting at different workstations for longer time. And in the second case, the capacity buffers are used such that the job does not wait too long at those work centers, and it will get completed by the due date. In the third case, I'm going to implement step by step. In the third case, we can start the first operation at a later time so that the job, it does not have to wait for a long time, And in the fourth one is ideal case, start at some point of the time so that it runs smoothly, flow without waiting anywhere. But this is ideal. It cannot happen in job shops, but I'm showing the ideal case. So therefore, my goal is, achieving the third. So try to finish by a due date, starting as late as possible. So my entire, methodology is based on this philosophy. So now let us see context, in a general context. Here you are seeing the flows of 105 products on a production line consisting of 11 operations, as you see, in this list. And each horizontal line represents one of these, the flow of one of these 105 products. And the yellow color represents the waiting time before an operation, and all small these colors represent operations. So here you see these jobs are waiting for longer time at this plating, because during this time plating is a bottleneck. The jobs are waiting for longer time, but here as time goes on, the jobs are waiting at the second stage of drilling. Drilling is becoming a bottleneck, and from here onwards, even the milling also becoming a bottleneck. But again, from here onwards, again this the plating is becoming a bottleneck. So the status of the resources, the bottleneck status of resources will keep changing because of changes in product mix. And when we start the jobs at the right time, then we can control the total waiting time of a job without affecting their completion times. So we can find now there are various methods you might know to control this production, like Kanban, mixed model value stream, quick response manufacturing, drum buffer rope method of theory of constraints, convip of factory physics, scheduling on whiteboards in Excel, even using a project management software or MRP scheduling modules, finite capacity scheduling. The last one is is my favorite. I have been promoting the application of scientific finite capacity scheduling. Okay, now what I would like to give a demo of this tool. So let me go to here. I'm opening a tool, Scheduler Lite, which is developed for job shops. I think some of these are blocking. Okay, so the name of this tool is Job Shop. One second. Scheduler Lite. It's mainly developed for job shop scheduling. It is based on finite capacity scheduling logic, so that it never overloads any resource unless we want. It supports fast and extensive what-if analysis, and also proactive capacity planning. It requires two types of data. One is a job data. You might call work order, production order. Normal, I use the word job, but here you may see as a project also. This table contains the basic high-level information of jobs. Each job has a job ID. It may have a priority number, and it may have a due date, and there may be restriction. So like holding time, until certain time you should not start. If you don't have such restriction, you could ignore that. So like I'm not going into all columns now. So this is a basic high-level information. And here you could see the routing information of a job. Click on any particular job in the left side column. Then you see in the lower table the routing information. The sequence number for the operation name, how many hours you're estimating. And then this column shows the predecessors. In what order these operations are to be done, you could give here. You can also see the corresponding diagram. It means all these are to be done in a strict sequence. But in some cases, it could be different. For example, look at the network diagram of precedences. So this job is nothing but production and assembly of 3 components. So operations 110 to 116, they belong to production of component 1. Then 300 to 360 correspond to component 2, and 500 to 550 operations correspond to component 3. When all these 3 components are made, they're assembled in assembly operation 900, followed by subsequent operations like painting, packing, shipping, and all. So it could have any level of hierarchy. It could be The diagram could be anything. As long as it's valid, it could be, the complexity could be anything. Okay, now here, okay, the next is the resource requirements. Normally, every operation requires a machine or a worker, machine and a worker, sometimes a tool, zig, space, table, likewise. So let me talk about the other set of data that pertains to resources. The lower table contains the list of all the resources. Each one can be assigned a calendar. Calendar is nothing but a weekly shift. All calendars are indexed as 1, 2, 3, so on. And the top table contains groups of resources: a group of assemblers, a group of machinists, a group of welders, a group of inspectors, a group of CNC machines, a group of lathes. Likewise, you could create groups of similar resources. But you could also have more generic groups. The definition of our group is all the resources within a group, they must be able to perform one function, one common function. So the resources could be totally dissimilar, but they should be able to perform one common function as alternatives. On the right side, you see the mapping between the resources and groups. For example, Charles, James, Manuel, Mark, they all belong to the assembly group. They can work as assemblers. Whereas David, Ronnie, Travis, only those 3 people can run this machine. So Charles and Steve only can run the digitization. So let me sort by resource now. So you could see that Charles is a senior person. He belongs to multiple groups because he has multiple skills. And for example, the Davis, could you see he belongs to only 2? So some new people, they may belong to only 1 group. So our tool allows, this scheduling tool allows multifunctional machines and multi-skilled workers, and also multi-resource requirements. An operation may require, a machine and also 1 worker from the group. So it may, the group the resource requirement for this operation is the machine, particular machine SCS, FC, and any worker in this group. But if you want 2 people, for example, now if this is a long operation, say 200 hours it requires, you could split that into 5 parts. For example, *5, comma. If you give use this notation, then our tool will split that long operation into 5 subtasks of 40 hours each and assigns 1 worker to each subtask. I can skip the other columns now. So I have shown you, the basic information of jobs and resources. But yeah, sometimes people ask, about calendar exceptions. If resource is not going to be available as per the calendar, how can we deal? So all these calendar exceptions, during what time it will be available, in spite of calendar, like overtime, during what times it will not be available, though it's supposed to be there, all that could be, that such information can be provided through this window. So now I'm going to schedule, all this workload now, starting from this time, today is 6 a.m. by default. So if you want, you could select a date and time to specify scheduled start time. And let us go ahead by due date. You have an option to schedule by priority or due date. If the checkbox is on, then all the jobs will be first sorted by the due date. And all the jobs with the same due date will be again sorted in the increasing order of priority number. And then all the jobs will be scheduled in that final order. If the checkbox is off, then all the jobs will be first sorted by the priority, the increasing order of priority number. And then all the jobs with the same priority number will be again sorted by the due date. So the status of the checkbox determine, which sorting criterion we apply first and which one next. But you have also another option. For example, if you want to expedite a job, which is quite common in job shops, expediting or accepting a rush order, you could set penalty 3. So once you set penalty 3, irrespective of the due date and priority number, this job will be expedited even at the risk of delaying some other jobs. But you could also set penalty 4, we expedite the job without affecting any other job, but by giving overtime to certain resources as required. One is a default value. So I'm going to schedule now all the jobs by due date. This is what many people prefer. So I'm this method, this tool implements 2 iterations normally. First, in the first iteration, it gets a schedule which is really good for on-time delivery and throughput. It's the best for on-time delivery and throughput, but it's not good for work in process and production lead times. So in the first iteration, we aim at the throughput and on-time delivery. In the second iteration, we improve through the production lead time and work in process. So if I check this box, both iterations will be done, but I'm not going to do now for demo purpose. So let me do the first iteration. I would show you the schedule and do the next iteration. So it took about 0.36 seconds, about half a second, to schedule 1950 operations of 97 jobs. And the shop requires about 3 months' time to complete all this workload, as you see in these 2 boxes. And the 4 jobs are expected to be late. So when demand exceeds capacity, late jobs are bound to exist. This table gives a job schedule summary. The job ID, part number, customer names, scheduled start time, scheduled finish time, the due date, compared to the due date, how much earlier, how much late it's going to be. If you give the revenue, you could see the cumulative revenue curve. And we call it touch time. How many hours it is scheduled actually. Forget the idle time, waiting time. So it really required only 12 hours. However, it's going to be on the shop floor totally for more than a day. So the last one is the lead time, production lead time. So you could sort this entire table in the increasing or decreasing order. Now, before I get into the Gantt charts, I would show you the resource utilization. During the planning period of 3 months, you see in the second column from right, the number of hours the resources available as per the calendar. Right now, we're implementing calendar 1, that is morning 6 to 2 p.m., Monday to Friday. So 40 hours a week. As per that calendar, these resources are available during the planning period for 525.5 hours. And this third column from right shows the number of hours the resource is scheduled during the period. And the last column gives corresponding percentage utilization of the available time. Let me sort them in the decreasing order. Now you could see SN Chemical is the bottleneck, almost 99% busy. And this MGFC, flame cutter, that is about 84%. The Daniel is 76%. Is quite sometimes is a bottleneck. And Charles is quite often busy. So now, even though this Haas mill is a 60% only, but it's very likely sometimes it's too busy, sometimes sitting idle. It happens in job shops. So you can do this analysis, utilization analysis for any interval by selecting the interval in these 2 boxes and clicking this button. But I would like to show you, on a daily basis. Sorry. Where am I? What did I click? Awesome. I think this is somewhat blocking. Let me move it a little bit here. Okay. The resource, here you could see the resource utilization on a daily basis. Let me put them in the order of utilization. and SN Camille 99% busy. Here you see three colors: the green, the gray, and yellow. On any day for any resource, the green color represents the number of hours the resource is scheduled on that day, and the yellow color represents the number of hours it is expected to be idle on that day, and the gray color represents the number of hours it is unavailable. For example, Saturday, Sunday, all 24 hours, the resource is unavailable. So you could scroll that if you want, and normally I don't do that. I remove these lines and zoom out sufficiently to capture the entire planning period. Then you see that if it says something green throughout, it's a continuous, it's a permanent bottleneck. But sometimes for some weeks it's continuously green. After that, for 1 or 2 weeks, it is yellow. So it means that it's idle for longer time. So this gives valuable information to shop managers, production managers, about how the resources are going to be used on a daily basis, so that the management make right decisions, like training some workers on different skills, and if you see some expensive machine idle, salespeople may try to generate more work for that. So let me go to the Gantt chart now. I'm showing you now the Gantt chart. I have to keep adjusting this bar. Okay, this is the simplest view of the Gantt chart. And this Gantt chart shows the schedule I got in the first iteration. As I told you, the first iteration is pretty, the schedule is good with respect to work in process and lead times. Here, the yellow color represents the waiting time of the job for a resource, normally bottleneck resource. I can also put due dates here. The starting point of the red line is the due date. So now let me expand this one to see the schedule in graphical form. Okay, still it's going, it has so many operations. So initially the first operation could be done in a few minutes. The resource is always available for that. Then until this time, like 19th January, the job is simply sitting idle, because at that time, this operation will be done by this machine MGFC. The reason is, the priority of the job is 60. These priorities are redefined based on the due date. So it means that there are 59 jobs with a better priority or earlier due date. So therefore, the job is competing with those 39 jobs and waiting in the queue behind them until this time. So the yellow color in our Gantt chart represents waiting time of the job for a resource, normally bottleneck resource. So if this is a perfect forward schedule, whenever the resources for first operation are available, push the job to the shop floor. So that is a policy I adopted. So then what happens? Then these jobs will get stuck at the bottleneck for a long time. That's what's happening. I would show you now the schedule of all 97 jobs in a single screen. So now you see here, I'm loading as early as possible. This is a perfect push. Lean manufacturing people, they don't like this at all. But what's happening here, the jobs are waiting for a long time because I loaded as early as possible. Now what I'm going to do, the second iteration, I will delay the start times optimally so that their completion times are not affected, but their lead times, production lead times are minimal, and the working process in the system is minimal. That's what I'm going to do. So I will, by clicking this button, I do that. But when I do, I have to specify how much waiting time I can allow. So there is a parameter here, how much waiting I can allow. I'm allowing up to 12 days. I want to schedule all the jobs such that no job should sit idle on the floor for more than 12 days. irrespective of where the bottlenecks will be, when they will occur, how severe they occur. I don't bother. What I want is no job should wait on the floor for more than 12 days. You can reduce the 12 days if you want, but it depends on the type of production. So you need some, at least 5-6 days to absorb, uncontrollable variation. So now I'm going to reduce that WIP. Now I got a good and second. This schedule I got from the second iteration. So here what I did, I pushed the start times into the future so that the jobs don't wait for too long. But at the same time, their completion times are not adversely affected. So this I call a lean schedule. So my point is, you release the jobs at the right times, so that you could be pretty confident of when you are going to complete the jobs. And also you can see the resource utilizations. If you want to improve that, look at the resource utilizations and experiment. If you improve the capacity, can I take 2 more minutes?
Yep. Yeah, you can take 2 more, Prasad.
Okay, thanks. I want to do a small experiment because now I see that this the output. This is a bottleneck. SN Camille is a bottleneck. Either I can run it in the second shift also and see the impact, or I can add one more machine. So let me, for example, add one more machine as a what if analysis. What I'm going to do now, that SNK mill, I want to try put one more machine instead of one. I will put 2 machines and see what happens to schedule. So with 2 machines, I'm going to schedule now. Right now, I am completing everything by 15th March. So if I reschedule, let us see what happens. So now, when I reschedule, I'm completing by 3rd itself. Means I saved 12 days. But then I saved 12 days by using the second machine. But how the second machine is used, this is always troubling me. Okay, now, maybe I can put somewhere here. Okay, where am I? So yeah, I reduced by 12 days. I want to show you the utilization of the second machine. Now let me scroll down. See that the blue color on each day shows the utilization of the second machine. So in fact, on this day, you don't need a second machine. More or less on the entire week, hardly you need a second machine. So you are seeing the utilization of second machine. Though it is 99% earlier, when you put the second one is not fully utilized. The reason is the utilization of that one is blocked by this machine, MGFC. This became a bottleneck. So I want to try one more experiment. And here, that MGFC, I want to put this machine also. One more machine, or I can try in the second shift. So let me try now. So before I go to the next one, I want to show you the comparison, what gains and losses in the completion times. Because I added, the job got delayed. It happens, plus minus a little bit. But these jobs gained a lot. Their completion times are advanced by 15 days, 13 days, 12 days, and all. Okay, now I'm going to schedule with the second machine for MGFC also. Let us see how much gain we get. Now, almost a month, from March 3rd to February 2nd, we advanced. So 90 days, I saved how many days? 13 days, 30 plus, about 43 days out of 90. I saved 42 days by running the second machine for both, MGFC and SNK mill. I would show you the resource utilizations now for both of them. Now you see both machines are fully utilized, the extra machines are fully utilized. So I did a small experiment for you. One more thing I can do, for example, if you want to expedite a particular job, you have an option. You could do that. Let me take one job randomly and I expedite see what happens. Last experiment. So let me pick up one job. say for example, 1072, let me copy this for tracking purpose. And what I will do, I will expedite by setting penalty 3 and save it temporarily. And I want to reschedule it and see the impact of that job. This is the one I think we selected. The Gantt chart, let me see the look. It came to the top. Now, let us see the compare. How much benefit we got. Now, that job, the one that we expedited, it gained 31 days. Along with that, these jobs got some advantage. These got 5 days, this 1 day, 1 day. And these jobs got delayed by 4 days, 3 days and all, because we brought that job, from the middle to the front. So as I told you, when you expedite, there is a problem, with delaying other jobs. But if you see carefully, though they're relatively delayed, but they're within the due date. So there's no problem, So previous completion time, current completion time, but even then, they're within the due date. So there's no harm. So these 2 experiments I did. Likewise, you could consider any number of one. Also, you could set different calendars, in different weeks. For example, if you think that, that the work is on and off for some resources, you could set different calendars in different weeks using this feature. So I would like to conclude at this stage, and maybe 2-3 minutes we can have question answer session.
Perfect. Yeah. Thank you, Prasad. That was a really informative presentation. Looking at it from scheduling and optimization perspective, it's really great to see the tools that are out there, especially for job shop environment. So we have a few participants here that might be interested in a question. Please put it into the chat and we can read it from there. The way this presentation came about is as part of the Industry 4.0 program, we were traveling through the Upper Peninsula and Northeast parts of Michigan too, where we came across a lot of smaller manufacturers doing job shop. And this past year, if it is anything, it's that you're looking at manufacturing environments where the costs are going up for your materials, labor is tight, but demand has also gone up. So one of the things that manufacturers have been seeing across the board is that we need to figure out a better way to schedule their production floor. And especially now when they're seeing that as their main pain point. So we worked around that to see what solutions are available for small manufacturers. And that's how we came about Optisol and Prasad.
And this is quite economical, quite affordable. It's not from sales point of view, but many job shops, they hesitate because they feel that the scheduling software is complex and very expensive. That's not true anymore.
Right. And if I'm correct, the Schedulizer Lite there is a free trial available, right, of 30 days?
Yeah, for 2 months, 60 days. Yeah.
Perfect. Great. And I just want to talk about the Industry 4.0 program here at the last few minutes. The role of this program is a regional effort in the Upper Peninsula and Northeast Michigan, where we are helping manufacturers identify and implement Industry 4.0 solutions. So that could include solutions such as Optisol, which is just presented here today, where we can fund up to 50% of the effort, up to $10,000 for the company. Stephanie, you want to go to the next slide? Perfect. So this is alongside the other statewide resources that are there. Automation Alley and Michigan Manufacturing Technology Center have resources available for the entire state. Automation Alley has an access to their Industry 4.0 readiness data and a bunch of resources. It's free to access for Michigan manufacturers. I highly recommend it. They also have webinars that they put up on a regular basis. And the Michigan Manufacturing Technology Center also does tech roadshows and tech assessments and recommendations. So our approach to our program is a little different. It's slightly different from the statewide approach. We take a more holistic approach to looking at the business. I know some of our participants here might already be aware since having gone through the process. We do financial analysis and other business analysis that we believe are value-added services to the company and help them identify projects for Industry 4.0 implementation with the potential for co-funding as well. As I mentioned, the two things that we provide is a detailed financial analysis. I'll give you a quick demo of what that can entail and the operational analysis as well. Great. So financial analysis, what we do is we do a ratio analysis by looking at the ratios of companies by comparing them to RMA data. RMA data is data that is provided from the Risk Management Associates data. So based on the industry that a particular company is, we'll use their financial data to compare it to industry peers so that you're able to look to see how do you compare up against your industry in terms of your gross margin, your margins and your expenses, your liquidity and your leverage, etc. Next slide. Another perspective is organizational health. This is where we help a company complete a questionnaire across 8 of its business functions. And using those questionnaires, we're able to create a score for your business across 8 business functions to help you identify which part of your business requires your focus and efforts to help grow. The idea of this methodology is called a value opportunity profile, is that the recommendations are provided in staged levels. They typically make its way into the company's into the company's strategic plan. And the first set of recommendations is helping the company bring all their 8 business functions into the same strength before proceeding and pushing them ahead. So if, let's say in this case, for example, you could see there's weakness in planning, leadership, and sales. So the focus of those recommendations will be in bringing those functions of the business up to speed with the other aspects of the company. To give you a quick example, risks in planning could be having all your customers located in a very small region. Risks in leadership could be not having a strong leadership culture or communication across the organization. So what we do through the recommendations is provide those strategic recommendations to address those risks. Next slide, sir. And that can in turn make its way into a business value maximization model. So using the finances, we can provide a rough estimate of the business's value and then provide the recommendations will tie into what that value will actually have in improving the enterprise value of the company. Say in this case, after the company implements its 3 levels of recommendation, the potential value improvement that the company can see is given there. So the idea behind this is you can think of 2 companies that have exact same, do the exact same thing, have the same revenue and same profitability, but can have 2 entirely different valuations because of the risk inherent in the business. One company can have strong market positioning and good branding practice and a strong leadership team, whereas the other company can have a not so strong market branding, leadership team, etc. And hence the company B will have a higher risk associated with it and a lower value. So the idea behind the value opportunity profile is helping companies identify what their business risks are across the 8 functions, as we've shown before this, and addressing those risks in a staged manner. And lastly, as we mentioned, we have funding that's up to $10,000 available for companies. It's co-funded that we can put towards specific projects that help companies in manufacturing operations. And as you mentioned, these could be a software solution such as Optisol that was presented here. We're also helping companies in the inspection process to improve manufacturing, to remove manual visual inspection and implement automated high resolution AI inspection tools. And many other solutions are potentially there that manufacturers could leverage. Perfect. And here is the contact information. If you'd like to learn more about the program, feel free to reach out to us and we can give you more information and get you through the program and see where potential projects that we could use to support. Great. And with that, I believe we are done.
Thank you so much, Vikash. Again, as he said, if you have any questions, please reach out to us directly and we can answer, get you connected to the right person or answer any questions that you might have. And we appreciate you joining us today. And hopefully we will be working with you in the future. Thank you so much.
Thanks to all participants and also thanks to UFM for giving me this opportunity. Yeah, thank you all.
Great. And we will also have this presentation recorded and available to be shared as well. And that link will be sent out to the participants.
Yes, it will. Excellent. Thank you so much.
Good.